Good morning, everybody. Hope everybody's enjoying this second snow day. We would have been focusing on specific heat today in class, so I'm going to talk you through just kind of the general concept of specific heat. It's a very basic equation once you understand the variables that are involved and how to identify them. So if you're looking at the PowerPoint, if you're looking at slide number 34, specific heat is a physical property because it's something that can be observed or measured. And every given substance, metals is typically who we focus on, has a specific heat. And specific heat is just the amount of energy required to raise 1 gram of any substance 1 degree Celsius or Kelvin. So let's go ahead now and take a look at slide 35, and let's just take a look at this equation for specific heat because this is what we're going to be using the most here. I'm going to start by writing it down, and then we'll go through and kind of identify the different parts here of the equation. Okay, so this right here is a new variable that you more than likely haven't seen before. And in this situation, Q is going to be measured in joules, and Q is a measure of heat. That is ultimately, when you see Q, you need to think of that as an amount of heat. Please note that it could also be represented with a lowercase q. I've seen it written both ways, but anytime you see a Q, it's going to be measured in joules, and joules is abbreviated with a capital J, and again, that's a unit of heat. You could also think of heat as a unit of energy, because heat is energy, and we'll talk more about that whenever we get back in class tomorrow. The second part of this equation is the M, and this is probably the easiest. This right here is the mass. Even though you do have to be a little bit careful on this, and we'll talk about why. And we understand that mass is measured in grams, or in this situation, it could also be measured in kilograms. Specific heat is CP, and this right here is something that you will either be given or you will have to calculate it. And you'll see on the homework that I'm going to give you here in a little bit, a lot of the values are given, but sometimes you do have to calculate it. What I want to stop and look at here and kind of focus on is pay attention to the units on specific heat. So the units on specific heat are joules per gram degrees Celsius, or you could see it written as joules per kilogram degrees Celsius. And why does that make a difference? Well, you've got to pay attention to, is that CP written as grams or kilograms? If it's written as grams, you need to make sure that your mass is also written as grams. If it's in kilograms, you need to make sure your mass is also written in kilograms. And again, I'm going to show you some examples of that here in a little bit. And the last part is the part that students tend to mess up on, which is kind of ironic because it's not a difficult part, delta T. You know that delta means change, and typically in chemistry we see that T represents temperature. So in this situation we're looking at a change in temperature, and the change in temperature is the final temperature minus the temperature initially. And again, these right here are going to be in degrees Celsius. You could see that written in Kelvin, but all the examples that I'm going to give you are in degrees Celsius. So that's kind of taking a look at the different parts of the specific heat formula. And now let's just jump right in and take a look at slide 36, and let's do a practice problem here. Slide 36 says, determine the specific heat of a substance if 25 grams of a sample absorbs 34 joules as it was heated from 21 Kelvin to 33 Kelvin. Especially for people who are weaker in math, I always start by writing out my formula. So I've got Q equals mass times specific heat times delta T. And keep in mind that delta T is actually just the final temperature minus the initial temperature. So I'm looking for specific heat. So this is my unknown that I'm going to be solving for. It says the substance is 25 grams. I'm going to plug in 25 grams. It says that it absorbs 34 joules of heat. So I'm going to plug in 34 joules right there. I know that I'm looking for specific heat, and then it tells me that my temperature change was heated from 21, so 21 is the initial, to 33, so 33 is the final. So 33 minus 21, close parentheses. From here, guys, it's simply order of operations. You're going to combine the 25 grams times 33 minus 21. So that would be 8 times 25. And right now, all I'm doing is combining like terms. So 25 times this right here ended up being 8 is 200. And that would be grams, degrees. Oh, no, not degrees, Kelvin, times CP. And again, I'm trying to solve for CP, so the next step is just to get the 200 over. So I'm going to divide both sides by 200. Okay, and so 34 divided by 200 is going to give me 0.17 joules per gram Kelvin is my CP. Now, don't forget here about sig figs, and this one is kind of unique and frustrating, but if you look right up here, we're going for two significant figures because the original givens in the problem, 2 sig figs, 2 sig figs, 2 sig figs, 2 sig figs, our answer is in two significant figures. Okay, so that's the general basis of the equation. That's the general how to plug the numbers into the equation. The next thing we're going to look at is that Q value can be positive or negative depending upon if heat is absorbed or lost. So if you're interested in hearing about that, please go ahead and click to the next video.